but are we doing, what is the sorcery? Are we doing real-time transcript production?
Yeah, I think so. Yeah, it's an experiment this meeting.
Oh, okay, cool. That is most excellent. I was like, which one of you all is typing as fast as she can? You, if you were a little less of a rock star, I would have trouble believing that. I have none. Ooh, oh, awesome. Cool. So we're looking at the chair slides.
Yes.
Fabulous. I'm glad to have you here. Not kidding. And did I wandered up here with a Coke Zero, and I wonder what I might have done with it. Oh, it escaped. Thank you, Cindy. And now that I have a Coke Zero in my hand, I'm alive enough to invite to welcome you all to the IETF116 HOTRFC session, and introduce my co-host, Liz. Hi, Liz. Liz did all the work in London, but missed all the fun on Sunday night. So this is the first time I've had an opportunity to introduce Liz in person to you. And I'm just watching what slides are coming up. So this session is under Notewell, so please pay attention to that. It's a little bit weird because the people who are getting up talking know that it's under Notewell, and we don't actually have questions or discussion in the HOTRFC sessions. So, but like I said, If you start to do something that would be covered by the note well, please note well. If you have not seen this, next slide, please. If you have not seen this before, we have a thing on meeting tips, and just please asking people to sign in using the Meet Echo Lite client from the Data Tracker agenda. No one will be speaking at the microphone except for the speakers and remote attending participants there and things like that. This is information that will actually be more helpful in a more normal session than what we're doing here tonight. Next slide. Yes, and just putting up resources for the IETF meeting. Again, this will be helpful for you. Okay, and here we are at the ground rules for participation. HOTRFC is how you make a request for conversation. It is a good way to find IETF people to talk to for various reasons, and we don't actually hear what those reasons are. Each person gets 4 minutes from when I say go to please applaud. And at 4 minutes, we start applauding, and that looks like this on the next slide. Yes, cool. So the good news is that all of the speakers will be applauded, and that will happen whether they finish early and get applauded then, or if they run right to 4 minutes and get applauded then and they stop talking. And then the next person, the next person will be ready to speak. We have 6.5 of our 8 people who had registered for this IETF to speak here in person. Mark Blanchett is at the airport coming through customs, so he's not here, but he's close, closer than he is in Canada. So it'll be pretty easy for us to hand over microphones. We have one, but we do have one remote presenter, and that's always good. So the thing is with HOTRFC is that we don't do questions and answers here. Each person who speaks is providing follow-up info. If you're here in person, you can follow the person into a bar, of course. But if you're not following presenters into bars to start a conversation, each person's material should help you find a way to contact them and a way to participate and contribute in helpful ways with them. All of the slides that they're going to be presenting are in the data tracker, and we'll be using that for all slides. And we are pretty much to letting the conversations begin. And let's stop on the next slide. Yes. Yes, absolutely. You remember when I told you about making sure that no, you're going to be doing everything else. I'm not completely incapable, right? So first up, we have Donald Eastlake talking about hiding IPv6 hop-by-hop options. And just to make sure that everybody knows, please, you can tell us next slide, the presenters can tell us next slide, next slide, next slide. And we'll do the right thing.
I'm going to start. Yeah.
Yes.
Hi there. I'm Donald Eastlake with FutureWay, and I'm going to talk about a particularly simple and elegant way to hide IPv6 options. It'd be nice if you displayed the time on the screen. But anyway, so what's the scenario? You have packets that are going through some area in the network, and unfortunately, sometimes these days, packets with hop-by-hop options get discarded or otherwise mistreated. And so you want to avoid that problem by doing something at the edges of that region. Next slide. So there's some assumptions here that you have a cooperating destination or destinations. You have the best effort service is okay. You don't actually have to execute the options in the area where they're hidden, because when they're hidden, you can't, the network won't see them. Next slide. So this is an IPv6 header, should be familiar to some people at least. It's kind of simplified IPv4, but you notice there's no options in the header. Instead, there's this next header field. And options are encoded by using a special next header value and putting them after it, in particular, the next header value 0. Next slide. So this is what an option extension looks like. It's called a header extension in IPv6, and you can put what the actual next following thing is, which might be the payload, TCP or something, in the next header field there. So it's the 0 in the initial IPv6 header that indicates options. Next slide. So this is the simple, elegant solution, at least in my opinion. You simply replace the 0 in the initial IPv6 header field with a to-be-determined new opaque IP protocol number. And then the problematic part of the network will not see the options. It will just say, I don't know, some unknown IP protocol, I'll just shuffle it along in the normal forwarding manner. And then at the egress, I assume the cooperating destination, you can switch back to 0. So notice that this involves a trivial change to the packet. You're changing the value of exactly 1 byte in a very simple deterministic way. It's easily reversible, doesn't change the size of the packet or anything like that. Next slide. So I believe that change is a very simple and elegant way of overcoming this problem. I'm interested in getting comments on this draft. If somebody wants to implement it, that would be great. And dispatch means I'm also not interested just in comments on the draft, but also comments on how people think that this draft or this idea could be progressed. How does that do on time?
Donald finished about a minute early, under 4 minutes. Be like Donald. And thank you for saying that, because, yeah. What are we doing? Anyway. Okay, so this is Thomas talking to us about VCon, and I am also timing you over here, so, and I will have nice big flashing.
Nice.
Yeah, that. So
Thank you.
go.
Hi, my name is Thomas, and I'm here to talk to you about a proposal for a new JSON format for conversations called a VCon. So the California Consumer Data Privacy Law says that you have the right to know what a business has collected about you and how it's used. I don't know of any other honest answer than to shrug. And if you've been anywhere near a call center in your life, you know I'm not lying. Next. For all the stuff that we have to deal with in terms of customer privacy, those things which are the most private are the hardest to change. For instance, if you look at this picture of myself, you'll see on the left-hand side things that were true for me in 1969 that are no longer true for me in 2023. However, except for the pixels, I look exactly the same. Next. So, you know, one of the things I've come to learn is that responsible organizations want to behave responsibly. Reputational damage to the ways in which they interact with their customers is very important to them. Yet, there is no standard by which they can do their jobs well, especially as it relates to the storage, analysis, and deletion of our most personal data, the recordings that contain our biometrics. Again, changing your name is way easier than changing your face. So the VCON standard is a proposal to express a conversation. Some people call it a PDF for conversations that contains 4 parts. The dialogues are the obvious part. It's the part that has, WAV files or, meta files or whomever you're going to record. They are the facts and the physics of the situation. And the parties identify who was in the dialogues. And I don't mean the old CDR way of parties. I mean the internet authority way. Who says you are who you are? If I were to record a Zoom call, Zoom would say it was Thomas, not just Thomas. The other 2, I think, are really what drive me into this project. The first is the analysis. You know what? I don't know if there's any other place in the globe that you can go and look at what pieces of AI have used your personal data. And they have companies have a responsibility to track which automations used your data. If you ask for your data to be deleted, those enterprises, those ethical enterprises, will delete the data that they used from you, including the things which we care about, the biometric faces and voices. And the attachments. Every conversation happens in context. The context of a car lead, I work for a car store, believe it or not, I work for a dealership. Or it's around a PDF or this conversation. Conversations have context. And the VCON standard allows you to deliver that across a network. Next. So here's the big use cases. First, privacy and customer data protection. I've talked about that a bit. And here's a bunch of questions that I just can't answer without a standard for how you represent a conversation. Is there personal information in it? I don't know. I can't tell you. Who's in there? No one's asserting any identity. The VCON standard is the platform by which you can build tools to answer these questions. Next. Secondly, we're living at this real intersection between the privacy of data and the robots. Vote for the people. People are better than robots. Thank you.
Let's put up his last slide that has the contact information and things like that while we trade speakers. Thank you. Excellent. Thank you, Thomas. And let's see. And I am doing that. Excellent. Yes. No. Okay, this is ridiculous. And that, and so we have Kieran talking about deterministic networks for industry operations and control. And I am resetting the timer. And we are ready for you to go.
All right. Hi, I'm Kiran from FutureWay, and I'm going to talk about this draft in .NET, but the goal here is to get a broader outreach because I think this work is kind of extends to some of the IoT work as well. Next slide, please. So this is the scenario that in industrial networks, we have had TSN, Ethernet, and your automation is achieved only on a factory floor. And now we have .NET technology, which replaces L2 to L3, but why not take it to next level and have some kind of cloudification so that you can operate these devices from the cloud. Next slide. This process automation general idea is that you have a controller that exchanges set of commands with field devices. It is relevant to many applications like smart factories, energy grids, and URLLC type of use cases as well. Our goal is to come up with a common interface from device to deterministic network. So deterministic network has done a lot of great things, but there is a gap how you connect your end devices to .NET. Next slide, please. And specific things that we will be looking on is how an application interfaces with the network. What is the practical means of mapping your requirements from a controller? How do you send the commands all the way down to the field devices? How do you integrate it over the cloud and support different kind of traffic patterns mentioned here? Next slide. So this is just call for collaboration and feedback on this work. The solution we will discuss in .NET, but it is based on IPv6 solution related to hop-by-hop headers. And if you want to know more about this, please read our draft or talk to me. I'm around here. Thank you.
Thank you. And let's see. So next up, we have Casper talking to about Autonomous System Information Service. And let me get you get us started here. Yeah. Oh yeah. And so that is okay. And I'm doing, whoops, sorry. I'm doing that. I'm starting it. So you are a go, and
Great.
you can just look over.
Yeah, thank you very much. Hello, everyone. My name is Caspar Schutijzer from SIDN Labs, and I'm here to tell you something about the Autonomous System Information Service, or ASIS for short. Next slide, please. So it's important to state that the ASIS is not some set-in-stone idea. Rather, it's an early-stage research project. With that out of the way, the ASIS is a self-hosted approach for sharing interoperability and policy information of a communications network. And next slide, please. I will contrast the ASIS to some existing systems so that you kind of have a feel what it is about. So we have some systems in the internet today, such as WHOIS or AirDAP, and also PeeringDB. And those systems provide information about autonomous systems or IP addresses or domain names. And those systems work well, but there are some disadvantages, some of them including that the fact that they are intended for public access, so they have a lack of access control. There's also the fact that they are centralized systems, and they often are rate limited. So if you want to request some information about a bunch of IP ranges, for instance, you may run into those rate limiting issues. The ASIS, on the other hand, is supposed to be the opposite of this. So, well, maybe there's still some rate limiting, but it's not as rate limited, and it's not centralized. Next slide, please. The idea, besides it being self-hosted, is also that we can use the ASIS to share more information about networks. By we, I mean, of course, like network operators. Some information that parties may be interested in could be stuff like technical contact information or security contact information. That's already available now, but we are thinking about some other interesting data, like maybe BGP routing communities, sharing them in a more standardized way, and also some other types of information, like which data laws apply to a certain network, for instance, or maybe information about the energy footprint that a network has, so that you can make routing decisions based on that. Now, this is just a list of ideas that we have, but we are interested to know if you have any more ideas. Next slide, please. So with that, I'm finishing up. It was a really brief introduction, but I would like to know from you, have you ever seen something like this being proposed earlier in the IETF? We have looked around, but we couldn't really find anything. Another question we have to the audience is, do you see interesting use cases for the ASIS? And finally, if you would like to collaborate, then also please contact me. So you can reach out to the email address that's over there, or you can grab me in the hallway. Thank you very much.
Excellent. So next up, we have is this Inesio or Niels, talking about RASP research group.
Do you have the timer?
Hello.
My profuse apology. And now you're running.
Hello, everybody. I'm Ignacio, and I am chairing the RASP research group together with Niels. Next slide, please. What is RASP about? RASP is about research and analysis of standardization processes, mostly about the IETF, also interested in other organizations. We plan to release open data sets, collaborate with different people, create tools, open source software. We have a charter, you can check it out. Next slide, please. We have already done some cool analysis. This is, for example, co-authorship of different drafts. Next one, interaction graph of different working groups by area. You can see how they cluster depending on the area. Next slide, please. And I know this is very exciting and you have a lot of questions and ideas about what to do next and you want to join us and collaborate. So please, next slide. Drop by our meeting on Thursday. Everybody welcome. Even if you have ideas, you want to collaborate, or you just want to come and check out what we are doing, please come over. Thank you very much.
I'm actually probably looking at the wrong place anyway. And yeah. Let's see.
Let us get the timer set up.
Yeah. So we have Ted talking to us about DNS resolvers as certificate validators, and I'm setting up the timer now. And okay, go.
Okay. Hi, I'm Ted with Seoul National University. My idea is to propose to use local DNS resolvers as certificate validators. Next slide. So right now, the end host, when a client makes a TLS connection, a secure connection, it receives a certificate from the web server or other servers with certificate. So it downloads one or more certificates, the web server and intermediate CAs, and the client should check whether each certificate is valid or not. First, the individual certificates should not be revoked, so you should contact CRL or OCSP server of the CAs. I guess it takes mostly software approach. Even if something is not, something is out of service, it will go assume that everything is okay. And it will validate the digital signatures of certificates. And after the validation, its result is not reused. Whenever it makes a connection, it should perform this validation process. So the certificate validation will burden certificate authorities. So they should operate CRL servers or OCSP servers or both. So OCSP stapling will mitigate the burden, but still CAs are concerned about running these servers 24/7. So my idea is that just as local DNS resolvers relieve the authoritative DNS servers of the handling DNS requests, if local DNS resolvers perform certificate validation on behalf of TLS client, and if certificate validation results can be cached for some time, then it will greatly reduce the burden of CAs, of operating CRL servers, OCSP servers. Next. Of course, there should be some conditions. There should be DOT or DOH connections between clients and local DNS resolvers. And local DNS resolvers should be trustworthy. Like, for instance, we can enforce some code integrity by using remote attestation and so on. Next. So, so this the issue of my idea. So how long can certificate validation results be cached or assumed to be valid? So who will decide or recommend the caching period? Local DNS resolver operator, CIB forum, client. Next. So overall, this falls back to the fundamental question, end-to-end communication model or mid-box can do many things model. Next. Thank you.
Excellent. So next up, we have,
Yeah, sorry.
oh, okay.
This is our remote.
Oh, yes, that's our, we have our remote presenter, Jean. Hi, Jean. Do you have your audio turned on?
I believe so. Can you confirm that you can hear me?
Okay, yeah, we can hear you.
All right.
Give me just a second to
Hi, everyone.
start
Meanwhile.
start a timer. Give me just a second to start a timer and go.
All right. Thank you so much. Next slide, please. Okay, so I want to introduce a concept we've been working for some time in my organization. My name is Jean-François, and I work for an organization called the IO Foundation. We are a tech NGO, and we've been trying to figure out a way to systematize a little bit part of the problems that I've heard in one previous HOTRFC in terms of how to define technically some of the things that are required in engineers, specifically when it comes to data protection. Next slide. So some of the problems that we identified was a misunderstanding of the nature of data. So there's currently 11 definitions for last count. So if we cannot get our heads around about what data is, so it's going to be very difficult to try to figure out ways to protect it. There's also difficulties on the life cycle of software, as well as this very strange burden put in the shoulders of citizens because of the current regulations, but also the lack of motivation of technologists because we don't really define for them a sense of purpose. And by the way, I forgot to mention before that the presentation of this particular concept, we believe that it probably sits in the application layer, but it may have some applications or some considerations on IP and transport as well. So that's the reason why we are presenting it here. Next slide, please. So we figured out a way trying to explain things such as human rights and so forth, but also digital rights. We figured out a way to try to put it in a much more algorithmic or technical way to explain it. Next. We also figured out a way to maybe come up with a definition about what is an actual human right versus what would be a digital right, what would be the proper way to define them in the basis of how do we define physical harms, but also digital harms. Next. And so we came up with this concept of a data-centric digital rights framework that has a number of things that we're working on. I mean, it's too long for the 4 minutes that I have. Next. Part of the things that we worked with was some very basic starting point principles, and we got 3 of them only. We'll try to keep it as short and sweet as possible. So principle 1 is I am my data. Principle 2 is end remedy, and principle 3 it's rights by design. Essentially, those 3 allow to have a sheet of paradigm in terms of specifically developers and engineers to think about how data is supposed to be treated or how could it be treated moving forward. Next. We also structured the framework in 3 particular layers. All of this, by the way, is very much on kind of an alpha version. That's why we are exposing presenting the project. Next. One of the outcomes of the framework that we are trying to work out is specific taxonomies for digital harms, digital rights, and also use cases for data. Next. The next steps of what we're going to be looking is we're going to be establishing a number of working groups, but also looking to research and release an MVP. And for that, we'll be asking for anyone who's interested in research strategies, documenters, and also possible policymakers. I know the IETF tends to be a little bit allergic to it, but it's always good to know how to enter this kind of conversations. Next. I'll surmise to you that we are not the people anymore. We are the cyborgs. If anyone thinks that this is an overreach, I would invite you to send me your mobile phones to Malaysia where I live, and we can have this conversation again in a week time. Next. There's a bit more of information because logically these 4 minutes don't really give too much margin to explain the whole gamut of what we've been working on. So that will be available in the slides. Next. There'll be easy ways to reach out to me. You can either send me an email, or I will also send a message on the thread. On the list. So anyone who wants to get in touch. Next. Thank you.
That was Jane. That was great, and thank you for finishing up right on time. Good job. So the last presentation we had on our agenda actually turned out to be Mark Blanchett's, and let's see.
The slides are in the data tracker. But
Yeah, his slides are in the data tracker under HOTRFC, and his title was, just to get that right, the title was title was Extending Quick for Large Latency Networks Such as in Space. For people who are interested in topics like that, I'd invite you to take a look at what's in the data tracker. I'd like to invite us to do a round of applause for all of our presenters, local and remote. And one thing, just as a minor administration kind of thing, I've been looking for someone who could help us with HOTRFC sessions in the future. And if this is something that you find value in and would like to help the community by contributing to making sure that we're able to continue to do HOTRFC talks at each IETF, please talk to me. That would be great. In the past year, the Secretariat has taken on much of the operational responsibilities for the talks, like making sure everything's in the data tracker and things like that. So it is much less work than it was a year ago when I was doing that alone, and it's a lot more fun to attend and a lot more productive for everyone. So, like I said, if you're interested in that, please let me know. Otherwise, I will thank Liz for doing an awesome job keeping me straight, and stay fresh, cheese bags. Yes. Oh, yes.
Hi everyone, this is Yoshiro Yoneya from JPRS. Tomorrow there will be a social session named Storytelling in Yokohama in noon. So I welcome you to join the session. It starts at 11:45 to 12:45. Very few lunch boxes are still available. So I welcome you come there, and please hear the stories regarding to Yokohama, its culture and the history. And it's very pleasure to say that high school students, 3 high school students tell the story. So I hope you enjoy the event. Thank you.
Exactly. And the crowd goes wild. That sounds awesome. I will return you all to the rest of your IETF meeting week Sunday evenings. And I hope you have a wonderful and productive IETF this week. Make good choices. Yeah. Okay. We did it. Good job. Excellent job. Excellent job. And so I am, now that I am not crazy and not sick, which one or the other of those, possibly both, is well characterized my participation in hot RFCs. So I'm thinking that big, definitely makes, it's a two-person job to make sure we get the timer started.
Yeah.
And I'm using an application that I only use once every 4 months here. So I had forgotten how to reset the timer to the original value. So I was having to reset, I was having to set it to 4 minutes each time. So
Yeah, we'll see if maybe we can think of something that maybe the presenters could also see, something, some way that we could make it.
yes. And so that would be brilliant. I'm also finding it is helpful for me to be looking at the agenda we have. And of course, and I'm sure this is all environmental care, but I'm finding it helpful for me to be looking at the agenda. What the